Yeah, good evening. Welcome to the next audio lecture. And last lecture I discussed about constructing a code tree for encoding the given message sequence using convolutional encoding through graphical approach. And in this lecture we discuss about the encoding of convolutional codes. Encoding of given data using convolutional codes through graphical approach and using a trellis structure. Okay, so in the previous lecture I said that um, the code tree has a repetitive structure after 3 stages or 3 branches, so we can remerge the states which are repeating. Okay, so the trellis is obtained from reducing the code tree, or we can say that a trellis is a compact form of a code tree. Okay, right? So given a convolutional encoder, we can build the trellis. Okay, so as I mentioned earlier, so for any given encoder we need to write down the state table first, so it is better to have a state table. Okay, so I'm writing the encoder first. So we are taking the same encoder, first output, second output, and see the multiplexer. Here the input. Okay, so for this one, in the last lecture I discussed about how to write down the state table. Okay, so input, present state, next state, and then output. Okay, so we need to consider the present state 0 0 with input 0, next state will be 0 0, output is 0 0. Again same state, input 1, next state will be 1 0, output 1 1. So this is A and this is A, this is B. And next we need to consider state B, which is 1 0 with input of 0. So next state will be 0 1, and output will be 1 0, and with 1 0 present state with input 1, next state will be 1 1, output will be 0 1. This is state B, this is C and D. And next we need to consider state C with input 0, the next state will be 0 0, and output will be 1 1, and with 0 1 input as 1, next state will be 1 0, output will be 0 0. This is C, this is A and B. And next with the present state as 1 1, input as 0, next state will be 0 1, output will be 0 1, with 1 1 as a present state with input bit 1, next state will be 1 1, output will be 1 0. So this is D, this is C and D. So we need to have this table. So with this table we can construct the trellis. Okay, so first point to note down, a trellis will have L plus K levels. Okay, so where L is the length of the message sequence, and capital K is constraint length of the encoder. Okay, and second point, the first K minus 1 levels are for departure of the encoder from the initial state. That means k minus 1 levels are required for the encoder to departure from the initial state. So in our case the initial state will be 0 0 state. Okay, and next the last k minus 1 levels are for returning back to the returning itself, coming back, so returning to the initial state. And remember, for the last k minus levels we consider only the inputs as zeros. Okay, so that means the last k minus levels, we need these levels for returning to the initial state. So to return to the initial state, so tile bits are necessary. Okay, tile bits will be always zeros. So for the last k minus levels, the input bits we need to consider only as zeros. Okay, right? So remember that point. And point number 4, so levels k minus 1 less than j less than or equal to L, the structure is periodic or repetitive. Okay, so from level k minus 1 to level k minus 1 to level L, the trellis structure is repeats, or you can reach all the states. That means the structure is periodic. Okay, so these are the few points you need to remember for drawing the trellis structure. So let us draw the trellis structure now. Okay, so state A, which is initial state, and B, C and D, j equal to 0 level. So as said, there will be total of L plus k levels, and the level number starts with j equal to 0. So the level index will be j equal to 0, comma 1, comma 2, and so on up to L plus k minus 1. So totally from 0 to L plus k minus 1, there will be total of L plus k levels. So this is level j equal to 0. We start from the initial state A. Okay, and always remember while drawing the trellis structure, input 0 will be indicated by a solid line, whereas input 1 will be indicated with a dotted line. Okay, and the corresponding output will be indicated on the branch or on the line. Okay, so from the table, when we are in initial state A, the next state will be A only. Okay, so if we look at the table clearly, when we are in state A, if input is 0, we move to state A only with output of 0 0. When we are in state A, if the input is 1, we move to state B, which is 1 0, and the output is 1 1. So with this information, so let us draw the trellis. So when we are in state A, if input is 0, input 0 means we have to draw a solid line. Okay, so we move to state A with output of 0 0. Okay, so when we are in state A, if the input is 1, we move to state B. So a dotted line, and corresponding output is 1 1. Okay, so when we are in initial state A, if the input is 0, we move to state A only. If the input is 1, we move to state B. Okay, and now by the time we are at first level, j equal to 1, so the initial state has been departed to 2 states only. Okay, so now again we need to consider input 0 and input 1. So when we are in state A, if the input is 0, we move to state A with the output of 0 0. When we are in state A, let us draw state B. So when the input is 1, then we move to state B with output of 1 1. Next, now we are in state B here at level j equal to 1. So when we are in state B, if the input is 0, we move to state C. Okay, so solid line with the output of 1 0, and when the input is 1, we move to state D with the output of 0 1. Okay, j equal to 2. Now see, for our convolution encoder, constraint length k is equal to 3 and capital K minus 1 is equal to 2. So j equal to 2. So the first k minus levels are for departure of the initial state. So we completely departed from the initial state. So now at level j equal to 2, we reach it to all the states. Okay, right? So now, and what we said earlier, from k minus 1 to L, the structure is periodic. Okay, so now consider this. We are in state A. If the input is 0, we move to state A with output of 0 0. So next, let me draw this. Yeah, when the input is 1, when we are in state A, we move to state B with the output of 1 1. When we are in B, if the input is 0, we move to state C with the output of 1 0. Similarly, when the input is 1, when we are in state B, we move to state D with the output of 0 1. Next, when we are in state C, we move to state A if the input is 0 with the output of 1 1. So when we are in state C, if the input is 1, we move to state B dotted line with the output of 0 0. When we are in state D, if the input is 0, we move to state C with the output of 0 1. When the present state is state D, if the input is 1, we move to state D only with a output of 1 0. So this is j equal to 3. Let us say the given message vector is 1 0 0 1 1. So in this case L equal to 5. So we need to draw 2 more stages where the structure is periodic. So next, again A, B, C and D. So again same procedure. When we are in A, we move to A only with output 0 0. When input is 1, we move to B with output 1 1. When we are in B, input is 0, we move to C with output as 1 0, and we move to state D when input is 1 with output of 0 1. And when we are in state C, we move to state A with output of 1 1, and if the input is 1, we move to state B with 0 0 output. So again, when we are in D, if input is 0, we move to state C with 0 1 as output. Again, when we are in D, if the input is 1, we move to state D with output of 1 0. So again repeating the structure. This is j equal to 4. Next, j equal to 5. So again drawing the same thing. Output 0 0, output 1 1, B to C solid line 1 0, B to D 0 1, C to A 1 1, C to B 0 0, D to C 0 1, D to D 1 0. And now this is j equal to 5, and the last k minus 1 levels, that is k minus 1 means last 2, that means the trellis starts at j equal to 0 to j equal to L plus k minus 1. What is L plus k minus 1 in this case? So 5 plus 3 minus 1, which is equal to 7. So from j equal to 5 to j equal to 7, so the encoder returns to the initial state, and we need to consider only inputs of bit 0. Okay, so now A, B, C and D. When the input is 0 from state A, we move to state A only. When the input is 0, state B, we move to state C with output of 1 0. When in state C input is 0, we move to state A with output of 1 1. When we are in state D, if the input is 0, we move to state C with output of 0 1. Now this is j equal to 6. Now we got only two states, A and C. Again we need to consider only input bit as 0. So now when the input bit is 0, we move to state A with output 0 0. And now in state C, when the input is 0, we will move to state A. Okay, so output is 1 1. So this completes your trellis. As you can see, this is the last level, which is j equal to 7. Okay, so the first k minus 1 levels are for departure of the initial state to all the other states. The last k minus 1 levels are for returning back to the initial state. Okay, for the last k minus 11 levels, we need to consider the input bits as only zeros. So see here at j equal to 5, I consider only zeros. When you are in A, 0 comes, we'll move to A. When you are in B, 0 comes, we move to C. Okay, and C. When we are in C, 0 comes, we move to A. When we are in D, 0 comes, we move to C. And similarly, when you are in A, 0 comes, we move to A. When we are in C, 0 comes, we move to A. So now we completely return to the original state or initial state. So this completes your trellis. Now, after trying this trellis, how to encode the given message sequence? What is the message sequence? 1 0 0 1 1. So let me write down here 1 0 0 1 1. Okay, so now let us encode the given message sequence. Okay, what is the first bit? 1. So from the initial state we have to take the dashed line because it is 1. 0 corresponds to a solid line, 1 corresponds to a dashed line. So I will take this path. So we stop it here. What is the output? 1 1. Next bit is 0. So from state B, because input is 0, we need to take the solid line. So I will take the solid line. I'll stop here. So output is 1 0. Next input is 0. Again we need to take solid line. So from C, dashed line is going to B, solid line is going to A. So solid line, I will go to A. What is the output on this path? 1 1. Okay, next input is 1. 1 means we have to go through the dashed line. Okay, so if you go through dashed line, from here we will move to state B. So this is the dashed line. What is the output? 1 1. Next input is 1. So from B we need to take the dashed line. So if you go through dashed line, from B solid line goes to C, dashed line goes to D. So we have to go through dashed line. So which is, so we stop it here at this point. What is the output? 0 1. Okay, so 1 1 1 0 1 1 1 1 0 1. So this is the sequence what we got earlier also. Okay, so in this path we will encode the given sequence. See, if you consider the tail bits, so now what is the tail bits? Zeros. So if you consider the tail bit, it will move to state C, it will move to state A, completely return back. So next sequence is 0 1 and 1 1. Okay, but up to this point it is enough. Okay, right? So after drawing the trellis structure, then encode the message sequence as explained now. Okay, so if your input bit is 1, followed the dashed line. If your input bit is 0, followed the solid line. Okay, so now write down the output sequences on this path. So 1 1 1 0, again this is 1 1, and this is 1 1, and this is 0 1. Okay, the output on the corresponding path. Okay, right. So this is how we encode the given message sequence using trellis structure. Okay, and note down from level j equal to k minus 1 to level L, the structure is repetitive. In this case, k minus 1 is 2, L is equal to 5. Now if you see this clearly, from 2 to 5, the structure is periodic. Okay, so the same structure repeats, right? So if you take the same structure which is repeating or periodic, so let us draw that structure. So A, B, C, D. Okay, so draw the trellis for one periodic structure. So A to A, solid line, it is output 0 0. A to B, it is dashed line, output 1 1. B to C, it is solid line, output is 1 0. B to D, dashed line, output 0 1. C to A, solid line, output 1 1. C to B, dashed line, output 0 0. D to C, output solid line 0 1. D to D, 1 0. So take one periodic structure. Now using this periodic structure, we can obtain the state diagram. Okay, so as we discussed earlier, there are three approaches. One is the code tree approach, one is the trellis approach, and the last one is the state tree approach. So in order to draw the state diagram, we can directly draw it from the state table itself, but so we can draw from the periodic structure of the trellis also. Okay, so now we indicate the four states like this: A, let us say B, C, and D. So now if you see clearly, when input bit is 0, that is a solid line, we are moving to the same state A, and the output is 0 0. So arrow mark. So when we are in state A, solid line represents input 0. We are moving to the same state with output of 0 0. Now when we are in state A, if the input bit is 1, we are moving to state B with output of 1 1. So draw a dashed line, and output is 1 1. Next, now B. When we are in state B, if the input is 0, that is solid line, we are moving to state C with output of 1 0. Okay, so solid line with output of 1 0. Now when we are in state B, if the input bit is 1, we are moving to state D with output of 0 1. So from B to D, arrow mark B to D, it is a dashed line, and output is 0 1. Okay, next come to state C. When you are in state C, if the input bit is 0, a solid line, output of 1 1. That means we are coming to A, arrow mark C to A, output 1 1. When we are in state C, if the input bit is 1, dashed line goes to B. So with output of 0 0. Now come to state D. If the input bit is 0, solid line, we are moving to state C with output of 0 1. So solid line with arrow mark and output 0 1. When the input bit is 1, we are moving to the same state, that is D itself, and output is 1 0. So dashed line arrow mark with output of 1 0. So this representation is called as state diagram. Okay. Okay. So what we discussed in this lecture is, for the given encoder, as usual we are going to draw the state table. We are going to draw the state table. So with state table with us, we can go ahead with the trellis structure, but in trellis structure you need to note down few points. The trellis will have L plus K levels totally, and L is the length of the message sequence, K is the constraint length. The first K-1 levels are for departure of the encoder from the initial state. The last K-1 levels are for returning to the initial state, and during this last K-1 levels we need to consider the input bits as only zeros, and from level K-1 to level L the structure is periodic. Okay, and the level is represented by a index j equal to 0 to 1 comma 2 comma and so on, L plus K-1. Okay, and in the trellis structure a 0 bit indicates, is represented by a solid line, bit 1 is represented with a dashed line, and the corresponding output is indicated on the branch. Okay, so this is how the trellis is drawn. So after the trellis is drawn, take the given message sequence and follow the path depending upon whether you got the bit 0 or bit 1. Okay, so trace this path from left to right and note on the corresponding output values. Okay, so on this path corresponding branches give you the corresponding output values. So in this way we can encode the given message sequence by using trellis structure. Okay, so take any periodic structure of the trellis, and from that we can construct the state diagram. Okay, right? So this is how we encode using a trellis structure. Okay, so last lecture we discussed about encoding using the graphical approach using code tree, and in this lecture we discussed about trellis structure and also state diagram. And you can encode the given message sequence using any one of these three, either code tree or trellis or state diagram. Okay, thank you.